Okay, so this question says that f of x equal x squared plus 3 all to the power of 7. Find the term in x to the power of 5 in the expansion of the derivative f prime of x. Alright, so first thing then, if we've got f of x is equal to this, we're going to need to find the derivative f prime. So here we've got quite a complicated function, so we're going to need to use the chain rule. So what I'm going to do first of all is let u equal x squared plus 3. So then I can say that f of u is equal to u to the power of 7. And then I can differentiate that and I'd get f prime of u is equal to 7u to the power of 6. And then I can work out what u prime would be and differentiate this. So that's going to give me 2x. So then that would mean that f prime of x is going to equal f prime of u multiplied by u prime. F prime of u multiplied by u prime, which is going to be 7 times the x squared plus 3 to the power of 6, and then multiplied by 2x. So I could simplify that, and I could say that f prime of u of x is equal to 14x and then x squared plus 3 all to the power of 6. Okay, so I've worked out what the derivative is. So what I'm going to need to do next is expand it so I can work out what the term in x to the 5 would be. Now, since I've already got 14x here, I'm going to need the term in x to the 4 from this expansion. So I'm going to need term in x to the power of 4 from the expansion of x squared plus 3 to the power of 6. So I could work that out, and it should be 6 MCR 4, and then I'm going to want x squared because I'm going to want x squared to the power of 2, aren't I? And then multiply by that 3 to the power of 4. So I've done that wrong here. This would not be 6, 4 because this is x squared here. The term which is going to give me x to the power of 4 is going to be the x squared 2. So I'm going to want the second term. So I'm going to want 6, 2. Which should actually be the same as 6, 4, but let's not confuse matters. So it should be that one. So that is going to equal 6 NCR2 is going to be, I guess I can do my Pascal's triangle for working out that. Let me just scroll down here and I do Pascal's triangle. So Pascal's triangle starts off 1, 1, 1, then 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. So NCR2 is going to be this one, which will be 15. So this is going to equal 15 multiplied by x squared squared multiplied by 3 to the power of 4, which is going to be 81. So I'm therefore going to have for the term in x to the 5 is going to involve the 14x and then multiplied by 15 times 81x to the 4. So that's going to give me, get my calculator out, it's going to give me 14 times 15 times 81, is 17,010 x to the power of 5. Okay, that concludes the question. Okay, this question says a particle P moves along a straight line its velocity Vp meters per second after t seconds is given by the equation here. Vp is the square root of t sine pi over 2t for between t is between 0 and 8. Following diagram shows the graph of Vp. We've got a little diagram here. So part A says write down the first value of t at which p changes direction. So p will change direction when the velocity, which is here, changes sign. So a positive velocity means it will be going in one direction. Negative velocity means it will be going in the opposite direction. So where we start off moving in the positive direction, and then at this point here we get a change in the sign of v. So at this point here is where we get a change of direction. So this occurs when t is equal to 2. Alright. Next it says find the total distance travelled by p for between 0 and 8 seconds. So what we're going to need to do here is do some integration and work out the area under the curve. So first of all, if we work out this area here, which we can do by integrating the curve between 0 and 2, this will give us a positive value for this distance. We would then work out this one, which would give us a negative distance. So we couldn't just work out between 0 and 4 because we get positive here, negative here, and we'd end up with the sum of those two. So we'd have to work out this one and then this one, and then we'd need to work out this one, and finally this one, and then combine all those values together. So what we need to do, just scroll down here so we can work this out. So A part 2, the distance travelled is equal to, so it's going to be the integral between 2 and 0 of square root of t sine, what was the equation? Is it pi over 2t and then I'm going to need to subtract the one between 2 and 4, so we're going to subtract between 4 and 2 because that answer would be negative root t sine pi over 2 t dt. Then I would need to add to the next region because that will be positive, which is between 6 and 4. And then finally subtract the last one because that would be negative, that would be between 8 and 6. Okay, if you stick all that into your graphical calculator, then that should give you the distance travelled is 9.65, I believe. Move on to part B. It says a second particle q also moves along a straight line. Its velocity vq meters per second after t seconds is given by vq as the square root of t between 0 and 8, and then after k seconds q has travelled the same total distance as p. Find k. So what we're going to need to do here is similar integration, but this time we're going to integrate square root t dt between k and 0, and we know that that is going to equal the same distance as we had before, which is going to be 9.65. So if we can integrate this here, input the values for k and then solve this, we should be able to work out what k is. So what I can do here is I can rewrite that as k and 0 t to the half dt is equal to 9.65. Then when I integrate this, I raise the power of a half by 1 and divide by the new power. So that will become t to the power of 3 over 2. Now I would divide that by 3 over 2, which is the same as multiplying by 2/3 between k and 0. That is equal to 9.65. So then I can put the limits in, and when I substitute in k for t, that's just going to give me 2k 3 over 2 over 3, and then this would be subtract. When I substitute 0 in here, I would just get 0, so subtract 0 is equal to 9.65. So then k is going to equal 9.65 multiplied by 3 divided by 2, and then to the power of 2/3. So k should equal 9.65 times 3 divided by 2 equals, and then I can do that to the power of open bracket 2 divide 3 close bracket equals. So that gives me 5.94.